2018. So that same technology developed in the 2 years that during the COVID time. Lot of technology developed. We are not aware of that this online classes using the Zoom, using the Google Meet. Okay, at the same time, it means now we can have the Google Meet, we can have the Zoom with low price. Even though wherever our families, maybe in other countries and some other places of in India also, we can gather to the all in one platform. We can see also, we can talk. Okay, so technology is developed a lot. The technology changing also nowadays in a very drastic way, fast. This is the way the technology developed. We know that we are aware of that everyone that how the technology fastly is developed now. So mainly, whatever the product we are developing, if we are starting the company or we have the mind to develop anything, so first the safety, okay, is very very important. So technology also developed or any new thing you are developing, okay, based on the lessons from the history. Okay, whatever your product you develop, so that product utilizing and in utilization process, some difficulties, some problems may occur. Okay, that problems or from the difficulties, we'll learn the lessons and we'll develop again. That we will modify it or will develop that product in a useful way, in a desired way, and better than the past. So now we can talk about the nanotechnology. You see that if you talk about the before going to that nanotechnology, discussion about nanotechnology, what is nano? If you see a healthy person, if any healthy person without any defect in a vision, okay, and any defect, nothing, no defect in eyes, okay, that person can see only with our naked eyes 0.1 millimeter. That means 100 micrometer, 100 micrometer, up to 100 micrometer we can see by our own eyes. Whoever they have the healthy person, okay, without any defect, they can see 100 micrometers. Below 100 micrometer, we cannot see with our own eye. But now we are talking about the nanotechnology. Okay, nanotechnology means we know that we are aware of that 1 millimeter. The 1 millimeter is equal to 1000 microns. Then 1 micron equal to 1000 nanometers. Okay, so below 100 microns we can't see with our own eye. But now we are in that nanotechnology. We are in nanometer. We are able to measure in a nanometer. We are aware of that. That if you see that even though Ferrari or Benz, the cost of that cars more than 50 lakhs or 60 lakhs, even the 1 crore, 2 crores. But the same facilities, and if you see our Maruti Suzuki, our cars, that maybe you will get at 7 lakhs, 10 lakhs, below 20 lakhs, you will get it. But the difference between that and this, mainly that of manufacturing. Okay, their surface, if you see, if you are able to make the surface, the roughness, almost make it the zero. Zero means the surface roughness you bring into the nano level. The peaks of the area, we will generally measure the surface roughness in terms of area, that is micron. If you are able to bring it to zero, nearly zero, so there won't be a that burnout in that. If you, for example, you take the piston cylinder between them, won't be there. If burnout will not be there, means that component lifetime is infinite. Okay, that is not at all possible. But we can reduce the surface roughness up to minimum level. Now we are able to, in terms of nanometer, we are able to fabricate that surface roughness. We are bringing down to the up to nanometer level. That's why they fabricate with the high precious using the high precious machines, and they are maintaining the surface roughness in terms of nanometer. That's why they won't the engine problems in that especially the engine capacities of that the Benz, Ferrari, what are the vehicles you take, the fabrication cost is very high comparatively our our Maruti Suzuki, this Tata, this all the vehicles. So that's why they perform well. So they are in the nano. They are able to measure. To measure the nanometer, we need the equipment to measure the nanometer. We need the equipment. Same with the high precious. So that should have the that equipment should be able to measure the nanometer, means that equipment should fabricate with a high accuracy. So that way we heard that in Germany they'll fabricate under the ground. They'll go to 7 floors of underground and they will fabricate, because fabricating any component, anything, lot of effects are there: noise effect, pollution effect, fabrication of the component, the vibration while machining, the vibration effects also there. So these all will affect on the dimensions. To get the accuracy dimension, to get the near net of the 100, for example, the diameter of the shaft is, for example, to get it 100 microns, set 100, 10 meter, 10 millimeter, or 10, whatever in terms of millimeter, or in terms of microns, in terms of take the whatever the dimension to get it 10 millimeter. So we are getting, now we are able to nearby that 9.9995 or 10.0001. We are able to now fabricate that that level, that accuracy of the fab component, because nanotechnology. Yeah, we'll see the nanotechnology definitions. Mostly we can see the nanoscience. What is nanoscience? Is the study of the phenomena and manipulation of the materials at atomic and molecular and macromolecular scales, where the properties differ significantly from those at a large scale. Okay, what we are doing, we are just manipulation of the material properties at atomic and molecular and macromolecular scales. So we definitely that where the properties definitely differ when in terms of large scale. Okay, nanotechnology are the design and the characterization, production, and applications of the structures and device and system by controlling the shape, size at a nanometer scale. Any design or characterization of any product or any structures and any devices, we are controlling the properties of that particular components or particular material by controlling the shape of that particular component and material and the size of that particular the material component at a nanometer scale. So now we are able to improve the properties in double or in more than double or three times, 4 times, or 6 times also. We are able to improve that particular component of the properties or behavior of that component, whatever the properties we need. So we are changing that material at a macro, nano level. Okay, mainly shape and size. You can see here, if you observe that 1 meter equal to, we know that 1000 millimeters. We can see this ant and flea. Okay, you see the ant is 5 millimeter size. You can see the 3 millimeter size. You see the flea 1 millimeter size. 1 millimeter. We can to understand the difference between the meters and millimeters and microns and nanometers. I just floated these figures. Please see. And you can see the micro scale. If we come to micro scale, 1 millimeter is equal to, we know, the 1000 microns. So this is the eye of the fruit fly and red the blood cells. This is the blood cells and this is the eye of the fruit fly. So this is the fruit fly, we know that. So that is 400 microns, and if we come to blood cells, 8 microns. Then nanometer scales. You know that 1 nanometer is equal to 1000. 1 meter, 1 micron is equal to 1000 nanometers. That generally that size of the 1 microns you can see in the viruses and DNA. So generally viruses and DNA sizes 1 micron, below 1 microns will be there. Okay. So this is the from here to here the dimension is 100 nanometers, the DNA, and this virus you can see from here to here is the 0.1 microns. These are the some images. So we can when you are analyzing the viruses and DNA, we have to go nanometer square. So nanoparticles. This is the nanoparticles, some images. So from here to here is the 1 nanometer. Nanoparticle. And we know that carbon nanotubes, buckyballs also. Nowadays, the carbon nanotube that uses is increasing a lot. Okay, so these are the some structures of the nanocarbon tubes and buckyballs. So nanostructures, we know that nanostructure, one is the 1D nanostructure and 2D nanostructure and 3D nanostructures. So now we are able to develop the nanostructures. We are able to use this structure, especially in medical application, bio applications. And now you see, recently, my brother, wife, they did operation. They put the mesh inside the womb. This type of nanostructure type of the mesh they put. So to some problems are there. To overcome that problem, they put inside the womb itself. And they said after the 1 month or 2 months, that will be disappear automatically. So that will be decomposition into the blood, and through that blood only it will come out. Okay. So that medical applications, lot of medical applications in aerospace applications, even the automobile sectors also, we are using this nanostructures, nanocarbon tubes, and nanowires, and biopolymers, and intermers. This all we are using in various applications, mostly in aerospace and medical applications we are using it. So now what is nanotechnology? What make the technology at the nanoscale differ from the technology at the macro scale? Okay. So nanotechnology, what difference you can observe in the nanotechnology from when you observe from the macro scale technology? To macro scale means up to micro level. So now we are in the nanometer. So we can observe that what differences we can observe, that we'll see now. While we understand that nanomaterials have the attract attention because of their unique physical, chemical, mechanical properties that differ from those of the bulk solids and molecules. Okay. Nanomaterial, they have the unique physical, chemical, and mechanical. Mechanical means all will come, that tribological properties also will come, corrosion properties under the chemical. Okay, and physical properties are the physical thermal properties also will come. Okay, so this all the properties have unique. These all the properties of the nanometers are unique, and they are completely different from the macro level materials. So nanometal exhibit distinct size dependent properties in the 1 to 100 nanometer range, where the quantum phenomena are involved. Okay. What is that quantum phenomenon says? When the particle radius approaches the asymptotic excitation Bohr radius, the influence of the quantum confidence becomes apparent. Now see why the difference when you reducing the size of the particle, when you reducing the size of the any objective, how the strength, especially in terms of strength, how strength of that component when using the nano material, how it can improve. You can see that the very large surface area of the nanometerial is one of the reason for their novel properties, and the high surface to volume ratio results in the high significant effects of the surface properties on their structures. This is the main reason, because we will get the high surface in terms of the high surface to volume ratio. We will get the high surface to volume ratio. Okay. Mainly the reason for the novel properties, we will get the high surface to volume ratio result in the high significant effect of the surface properties on the structures, especially when you nanostructure we are using, we will get the high surface. So that because of that high surface to volume ratio, we will get the higher end properties. Intensive research is being done for the use of the nanomaterial in many applications such as energy storage, energy conversions, solar cells, and pharmaceuticals, and life science applications, and optoelectronics, and sensing, and actuation nanosystems, and catalysts, and composite material. So, lot of applications: energy storage, energy conversion, solar cells, and pharmaceuticals, and life science applications, optical and sensors, and many other applications. We are using the nanometer nowadays. The volume ratio, volume to surface ratio. For example, an objective smaller than the have a much greater surface area to volume ratio. How will you can any objective having the small, if you reducing the smaller size of the objective, it having the greater surface area volume ratio, surface area to volume ratio. How you can see? You can take here 2 centimeter cube, okay, then 10 centimeter cube. If you take the 2 centimeter cube has a surface area of 24 centimeter and volume 88 centimeter cube. If you take the ratio, surface area, the surface area to volume ratio, surface area 24 by 8, that means 3:1. Okay, 3:1. You to take the same 10 centimeter cube, surface area 600 centimeter cube, and volume the 1000 centimeter cube. Ratio 0.6:1. So we are getting the highest the surface area to volume ratio when you are reducing the size of that object. So because of the surface greater surface area to volume ratio, we are getting the higher end properties. Okay, you can see some applications: antibacterial effect of the silver, some medical applications, and coatings. We are using the self-cleaning windows and snail-proof the clothing. In this coating, we are using the nanometal coating, and microchips. We are developing the microchips with the help of the nanomaterial. Even though our cell phone now you can see that SIM card, micro SIM cards we have, and the sunscreens and cosmetics also we are using the nanomaterials, and some other applications, catalysts, and food, and nano remediations, and paint, paper, cloths, filters, and batteries, and toothpaste, and cleaning products. Okay. Many other applications, lot of applications. Nanotechnology takes a place in many lot of applications. We have almost in every application to take nanotechnology involved. Now we'll see the properties of the nanomaterials. Properties of the nanomaterial. The particular application of the engineering materials, okay, in manufacturing engineering depends upon the through knowledge of their particular properties under the wide range of conditions. Whatever the material if we want to use, okay, we should know the behavior of the material under the load or under the environmental condition or under the external conditions. What are the conditions? Okay, the harsh environmental, chemical conditions, or at a temperature, environment condition, harsh environment condition, and under the external loads. Okay, whatever the load, how the behavior of the material. If we are able to understand properly that behavior of the material, then we can recommend that material for a particular application. So whatever the engineering applications, that mainly engineering application, if you want to use any material, or that material if you want to fabricate, manufacturing for any component, first we should know the behavior of the material under the different conditions. The term property, properties, that condition generally we can call that properties. The term property is the qualitative or quantitative measure of the response of material to the extremely imposed condition like forces and temperatures. The property terms represent to that qualitative or quantitative. So that we, in terms of qualitative or in terms of quantitative, we are measuring the response of the material under the forces, under the external loads or any loads, and temperature and the environmental condition. However, the range of the properties found in different classes of material is very large. Okay, different materials as material sizes as material sizes you are reducing, the properties of the material definitely may enhance or may decrease. For example, to understand that, if you take any material, if you are reducing the grain size, if you are reducing the grain size, then you are increasing the surface to volume ratio. Then as you reduce the grain size, then grain boundaries will improve. To detect that, to detach that boundaries, we have to apply the more load. So that means if the grain size is heavy, the grain size is a higher grain size, then volume to the surface area to volume ratio is low, then grain boundaries also lower. But then you can, when you are applying the load, the detachment between grain bond, means bonding between the atoms may be low at low load also there is a chance to get the detachment. As you reducing the grain size, then grain boundaries increase, surface to volume ratio increase. Then to detach that bonding, we need to apply more load. So as you reducing the size of the material, that means grain size of the material, then directly you are that improving the properties of the material. So we know that the classification of the material, mechanical properties, sorry, material properties. Under the material properties, we know the chemical properties, physical properties, mechanical properties, and dimensional properties. We'll focus on the mechanical properties. So since the topic is mechanical behavior of the nanomaterial, so we know that the chemical properties also very important. Physical properties also very important, and dimensional size and shape is also very important. The mechanical properties are very important, since we are working on materials, and that material we are developing for the various applications, and mostly the strength of the material, and hardness and toughness, stiffness, elastic and plastic property, ductility, brittleness, hardness. This all we have to analyze much more, because for various applications. So mechanical properties, the properties of material that determine its behavior under the applied forces known as the mechanical properties. Okay, at various the applied external forces, how the behavior of the material. Okay, the behavior of the material at external forces only, we can say that it's a mechanical properties. We know that they're usually related to the elastic and plastic behavior of the material. Material may undergo the elastic behavior or plastic behavior under the load. These properties express the functions of the stress and strain. A sound knowledge of mechanical properties of material provide the basis of the predicting the behavior of the material under the different load conditions and designing the component out of them. So if we have very good knowledge, that sound knowledge of the mechanical behavior of the material under the various conditions, various load, then you can design, or you can use the component for the whatever the applications. You can easily design, or you can design means you can easily recommend that material for the various applications. So mainly stress and strain. The experience shows that the material subjected to the load may either deform or yield or break, or depending upon the magnitude of the load, how much load we are applying, the nature of the material, what is the behavior of the material, then cross-section dimensions. So these are the main three effects when material, how the material will behave under the external loads, under the forces. If you see the length in scale wise material behavior, in the length is scales wise, take the meters, in millimeters, in microns, and nanometer. The behavior under the load, means how the defects, how the cracks, how material will get break. We take that is jet engines, 1 meter, that macro structure, at 1 meter macro structure, that 10 power minus to 1 meter, that behavior of the material. Then when you analyze at this range, in this range you can analyze, then we'll understand the different nature about that material. When you come to that in microns, here you can see the micro machines. If you analyze the material at a micron level, then you will get a different idea. And if you analyze the nanometers, then you will get a different idea. You can see the crack in the human teeth that in 1 micron. If you see, generally we won't observe this type of the cracks. Even though same with the jet engines also, even though that jet engines, if you see the micro cracks occurs, that leads to huge damage. So that micro cracks generally when you observe by your own naked eyes, you cannot see. If you go to that SEM with the help of the SEM analysis or with the help of the optical images, whatever it may be, we are able to observe the micro cracks. Okay, the micro cracks also create a huge damage, especially in the aerospace, because that aerospace the speed is very high. Okay, opposite force also act a lot of opposite force. So it may be for automobile sector, micro cracks may not affect much more, but in aerospace application, micro cracks leads to the huge damage. How material get failed? We know that by plastic deformation or yielding, or by fracture, or by fatigue, or by environmental conditions, or by corrosion or wear surface damages. Okay. So we'll see. We can see the failure by the plastic deformation. The plastic deformation of the because of plastic deformation, the bridges, the collapse may occur. Because of the plastic deformation, the bridges may the collapse may occur. And impact load. See, then 500 T2 tankers and 2000 Liberty ships were built during the Second World War, and they also got breakage because of the impact factor, sudden load. If the material is not able to withstand the impact load, then sudden break factors that lead to the huge damage. At the same time, fatigue fracture. See, this de Havilland first commercial jet aircraft had 5 major crashes in 1952-54 period, caused by the fatigue cracks. Caused by the fatigue crack initiated at a square windows. That's why now you can see the flight. The only they used to square windows. Now we are that oval shaped windows. We are able to see in the flights. Okay, so fatigue load. If we are not able to design properly, that if we are not able to use the proper material at the particular whatever the external force, what type of the force acting, then that leads to, it may be small crack or small damage, but it leads to the huge. And failure due to the burnout, wear behavior, because of the rail, okay, rail and the wheel, the between them. Where occurs more, the material removal rate occurs more. The rail collapse leads to the derailment of the locomotive in UK 1981. Because of the worn out of the surface, then it leads to the huge damage. So, if you understand about that, how material will behave under the different load, how material will get the fracture or failure on different conditions. So you can, if you analyze that, we can overcome that this type of the difficulties. We can try to overcome with the help of the nanotechnologies. Maybe coating, nano coating. Okay. For example, we cannot use the, for example, in the rail, you cannot use the high wear resistance material, because a rail that iron is the economical material available. If you want to use the ceramic material, or if you want to use the titanium, platinum, the type of which are material high wear resistant material, if you want to use that, cost is very high. You cannot use the with that much cost. You cannot invest and you cannot put the rails. So iron is the economical material we can use. So what we can do now with the help of the nanotechnology to improve the wear resistance, to improve the surface property, we are able to apply the coating with the help of the nanomaterial. The coating cost is very low. So that's why the nanotechnology now is a very, very useful tool, useful technology to overcome what are the problems we have discussed. We are able to overcome this type of the problems. Instead of increasing the cost, with the help of the nanotechnology, we are reducing the cost. We are at an economical level. At economical level, we are able to overcome all the problems. At a very small size, physical and all the properties of the material can change dramatically. Okay, nanomaterial can be used to improve the or change the properties of some product and alloys and composite material. Okay, nanomaterials. When you add the nanomaterial into the, for example, to understand that in aluminum composite, when you add the nanomaterial into the aluminum material, for example, you take the silicon carbide particles, silicon carbide particle macro level, micro level particle size, if you add into the aluminum, and the nano level particles if you add into the aluminum, when you compare to the base material of the aluminum, whatever the material we add, that properties may definitely enhancement will be there. But when you compare to the macro particles and nanoparticle, when you add the lot of researchers have already published the many papers, they have stated that when they added the nanoparticles into that aluminum composite, aluminum material, that aluminum material of the properties of the aluminum enhanced when compared to the micro particle enhancement more in the when they added the nanoparticles. So in the work effect of, for example, if you see by Yes Ahin and K.E. Kosho, they have published the paper effect of the aluminum oxide nanopowder on the wear behavior of the nickel titanium shape memory alloys. Okay, what they are prepared the nickel, the titanium nickel based shape memory alloy, and they developed the composite material using the Al2O3, that aluminum oxide nanoparticles, by powder metallurgy method. And they investigated some mechanical properties like hardness. They have observed that hardness and wear and corrosion behavior, and found that the lower wear rate is obtained when they added the nanomaterial Al2O3, that aluminum oxide particle. When they added, they observed that lower wear rate, that means wear resistance is high, and they observe the high hardness and corrosion rate also. They have corrosion resistance also high end. They observed it. Means the behavior of the material, properties of the material are changing drastically when you add the nano level particles into that base alloys. Yes, it's a researcher's topic on the mechanical properties. Mechanical properties of the nano particles have become increasingly hot in recent years. Now we can see that a lot of papers are published. So from 2003 to 2012, they published about nearly 300 papers. They published related to the nano material. And now you can see that now yearly are publishing more than 500 papers. They are publishing the nanomaterials. The work is going on throughout the world. So more than 1,000 papers, more than 500 papers they are publishing throughout the world. See, that means how many people, many people are working in a nanomaterial. So it's a very good research area, nanomaterial, the nanomaterial area. Very good research area. You can publish papers, you can get patent, we can get a project, a funded project also. We also recently, we got the one funded project. We are also adapting the nanotechnology to develop the bus stops for the elderly people. We recently, we got from the DST, nearly 25 lakhs funded project. So we can see that some of the people, some of the research, Donath, he also fabricated aluminum composite reinforced with the silicon particles, nano silicon particles. So he observed that micro silicon particles he incorporated in that aluminum, and all nano silicon particles they incorporated by steel casting method, and they have observed that when they incorporated the nano silicon particle, they observed the better properties of the aluminum composite material. So these are the 10 images of the silicon particles, the nano silicon particles. See, they have observed that grain size is reduced when they added the nanoparticles into the aluminum, and hardness increase and wear is reduced. That means wear resistance increase. Then they add the silicon nano silicon particles. So when they added into the aluminum, say nano silicon particles, it affects the lot on properties, wear properties and hardness and grain size also. Now we'll see how we can characterize the nanoparticles, nanomaterials. We have different techniques to analyze the nanomaterials, because with our own eye we cannot see the nanomaterial. So we have different the equipment to analyze the nanomaterials, electron microscopy, then scanning probe microscopy, especially atomic force microscopy, and X-ray diffraction, and neutron diffraction, and X-ray scattering, and X-ray fluorescence and spectrometry, and acoustic wave technique, and constant angle measurement, and various spectroscopics. So these are the equipments available nowadays to analyze the nanomaterial character, the nanomaterial metallurgical analysis of the nanomaterials. So many articles, many papers they have published. They have analyzed the structural of the nanoparticles by using the any of one of any of this equipment, and they have used and they have analyzed of the nanoparticles, nanomaterial, their metallurgical behavior of the nanoparticles. See, one is the atomic force microscope is the one of the powerful technique that can be used to obtain the both high resolution images on the many kinds of the solid surfaces, and the vertical forces as well the lateral forces between the sharp tip and the surfaces. So one of the equipment that we have, atomic force microscope, is a powerful equipment. With this equipment we can analyze we can place their sample, and we are applying the laser beams, and they'll reflect here with the help of sensing detectors, and we'll get the final here the image. Okay, so with the help of the atomic force microscopy, we can analyze the that structure, and how the structures and what are the elements are induced in that material. Okay, nanomaterial structure we are able to understand with a very clearly, and with a clear cut we are able to understand with the help of the atomic force microscopy. Now other techniques you can see, RBS, Rutherford backscattering, that we are utilizing the utility of that Rutherford backscattering, that is called the quantitative and qualitative element analysis. Then SANS, the small angle neutron scattering, that one of the technique. Then surface characterization and nuclear reaction analysis, that is NRA. With the help of this technique, you can understand that the depth profiling of the solid thin films, and RS, the Raman spectroscopy, you can vibration analysis inside that material. Then XRD, X-ray diffraction, crystal structure, we can observe how the crystal structure arranged. Then EDX, energy diffraction, X-ray spectroscopy. With the help of that element analysis, what are the elements are there? The element analysis. With the help of that XRD, we can analyze what is the weight percentage of that particular element. For example, aluminum, what is the weight percentage of aluminum? If it is the iron is there, what is the weight percentage? What are the elements are there, and what is the weight percentage of that element also you can analyze. Then XAXS, that is small angle X-ray scattering. With the help of the surface analysis, particle size you can measure up to 1 to 100 nanometers. Then CLS, then catholuminous scales, that with the help of that we can analyze that characterization emissions. Then NMR, nuclear magnetic resonance spectroscopy, with the help of analyzes the odd number of the nuclear spaces. So we have different techniques nowadays available to analyze the nanomaterial, to understand the completely about the nanomaterial, so that we can use that nanomaterial in various applications. Mostly nowadays we are using the nanomaterial. Because of once nanotechnology came, nanotechnology now more we are using the more percentage in the medical and the aerospace. So medical side, lot of changes occurs because of the nanotechnologies. Then structural characterization and compositional characterization. So we can divide into the two. Then structural composition of the nanomaterial and composition characterization of nanomaterial. Structural means we can use the SEM and TEM and STM and AFM and HRTEM. These are all the structural applications, structural analysis. Then composition characterization, mass spectroscopy, that is bulk composition, and AES, XPS, SIMS, and X-ray, XRF, and XPS. These are all the composition analysis. So what are the elements are there? what weight percentage element, that all we can analyze with the help of this all type of the equipment, and we can analyze the structural characterization by the SEM and TEM and all the remaining all the techniques. With the help of all the technique, we can analyze the structural characterization. You can see with the some images of nanomaterial. So we can observe that some image of the silver nanocubes. These are the silver nanocubes. If you see, this is the 250 nanometers and this is 1000 nanometers. So silver nanocubes. These blood cells, we can observe that with the help of the SEM analysis. And with the help of the TEM image of nanoparticles, if the TEM image of the gold nanoparticles, you go see the gold nanoparticles. With the help of the TEM analysis, we can understand that behavior of the material. Maybe porosity is there and cracks are occur or not. Then everything, how the atomic structure arranged, how the particles are arranged, grain size, everything we can analyze with the help of the TEM and SEM analysis. Then why is that at present interest, okay, then concern about the nanotechnology? There is so much interest. Why the so much of interest at present? Because we have it's a enormous potential. It's a very good, it's a means potential technology, and also huge gaps in the knowledge and concerning the possible risk. So lot of gaps is there between the knowledge and concerning the possible risk. Still lot of research are going on. That's why lot of interest, lot of people are working on this area, or many people are publishing, because lot of gaps still are there. Difficulty in detecting and removing. It is very difficult to detecting and removing. So the research is still going on for detecting and removing. Absence of regulations. Okay? Absence of the regulations. Because of the absence of regulations, also the lot of interest and concern in the nanotechnology. And potential risk associated with the nanotechnology. What are the potential risks associated with the nanotechnology? Then we can see the adversary health effects in a human from the deliberate or accidental exposures. Adversary health effect and adversary effects on the environment from the deliberate or accidental exposures. If the accidentally exposes or deliberate exposures, now we are suffering, all over the world suffering because of the COVID. That size of the virus is we unable to see. It's a nanometer size. So that maybe accidentally it came out or deliberately they sent out, or we don't know exactly. Okay, but now we are suffering because of that. Okay, still that how to control, because nano we cannot see by our own eyes. That's why accidentally exposing or deliberately exposing, that create lot of problems. That leads to huge damage, even though in terms of human death, in terms of machinery damages, whatever it may be. So that's why still a lot of research going on, since we are unable to see in nano level that whatever that it in terms of material, in terms of that virus, whatever it may be. So because of that, lot of research is going on still. Then potential explosive properties of the nanostructure. Potentially explosive properties of the nanostructure. Because of that also. And Grego is the nightmarish scenario of the nanotechnology, in which out of the control of the self-replicating nanobots destroy the biosphere by endlessly producing the replicas of themselves and feeding on the material necessary for the life. So these are the some potential risks are involved in the nanotechnology. And risk as assessment problems, very difficult to detect without sophisticated equipment. So it's very difficult. Nanotechnology very good for our daily applications, okay, to become easy, but there are a lot of problems also there to detect or to identify that without sophisticated equipment it is not possible at all. Okay, with the sophisticated equipment only it is possible. And difficult to predict how particles will behave in the environment. It's very difficult to predict how the particle behavior in different environment. And the small size may result in the particle passing into the body more easily. The small size, they'll easily pass into our body easily, because it's a nano level. The difficulties are there. That may damage huge. Okay, maybe if you are, for example, to understand that we are working in the harsh environment, there in the nanoparticle size, maybe whatever the harm to our body, that type of the particle, if there people may be passing to our environment, then that will go to our mouth, through our nose or through our mouth. It will create a lot of problems to human beings. May be more reactive due to the surface area to volume ratio. So because of the high surface to volume ratio, the reactive is more, and potential to absorb the toxic chemicals. Potential to absorb the toxic chemicals. These are some research areas. So gaps are there. We can work on this. We can try to reduce, or we can try to overcome this all the problems. And persistence, longevity particles in the environment and body are unknown. So a lot of the particles, particles are there in environment, in our body also, which are unknown to us. Then toxicological difficulties. All structures are likely to have a unique toxicological profile, and standardized terminology agreed recently, and particles may be less important than the surface characterization of the material, and standard dose response the test may not be appropriate. So these are some toxicological some difficulties around us. If you take the carbon nanotube, finally I'll conclude with the carbon nanotubes. Carbon nanotubes, the structure is like this. If you go through the up to 100 nanometers, with the help of the scanning electron microscope, we can see the carbon nanotubes. So we have carbon nanotube using that commercially produced by the companies such as Thomson Swan. They are able to produce. They are developing the better desirable product. Okay, shuttle bat with the help of the carbon nanotube. They have the high strength. Okay, carbon high strength, and then potential application of the carbon nanotube, material and chemistry, and the electronics and the ICT, and the medicines and the life sciences, and the energy storage or energy transfer. Okay, hydrogen storage, energy storage. Okay, super capacitor, solar cells, fuel cells, superconductivity material. We are developing with the help of the carbon nanotubes. And carbon nanotubes have the raised concern due to the superficial likeness to the absence of fibers and extremely durability, potential exposures during the manufacturing and processing product used at disposal have been researched more than most manufacturing nanostructures. So these are some carbon nanotubes. The research gaps are there. Research result, some coated CNT appear to move freely throughout the body, and insulation experiment have this they shown inflammatory fibrotic and immune changes, and these are the effect on the immune system, effect on the cell growth and death, modification of the tube coating by the aquatic organism. So these are some areas, research areas. You can go if you are interested, take these areas and do the research in these areas. You can publish easily, and we can get the patents, and you can get the easily funded project also. These are some research gaps, because since nanomaterial are unable to see, a lot of problems also there, lot of advantages, we have a lot of uses also there. So if you are interested, take up all the problems as a research areas and try to give some solution which is useful to our human. Thank you. Thank you, sir. Any doubt?
Okay. Thank you, sir. So if anybody has any doubt, please raise your hand. We can ask. Yeah, before that, I would like to thank Dr. Praveen sir for taking this session nicely. Thank Praveen sir for taking this session nicely. So thank you, sir, once again. Okay. For tomorrow, tomorrow will be the last day of our FDP on novel materials. Tomorrow we'll be having 3 sessions. There will be one technical session in the morning from 10 to 12, and from 12 to 12, from 12 to 2, one more talk is there, that is on stress management and emotional strength. As per AICTE Atal guidelines, we have to have one session on emotional strength, or we can call it, we can also call it as stress management. One deputy investigation general officer, DIG, designated IG also from Central Security Force, CSIF. He is going to take that session. I hope, I request each and every one of you to participate in that stress management session. That is from 12 to 2. So, and then final session will be feedback session. Those who are willing to give oral feedback, you are welcome to give the oral feedback about the FDP. And also, there will be written test tomorrow. There will be written test. You please appear in the written test. And as you all know, that 60% marks should be scored in the written test, and 80% of attendance should be there. Of course, attendance I will upload in the Atal portal for all your presence. I will see your attendance from the Zoom portal, and accordingly I will update your attendance in the Atal portal. And tomorrow evening from 3 o'clock session will start. Initially there will be a feedback session. After that, written test will be there. Okay. So I will send you the Google form of the exam sheet. So you have to appear in that test, and you have to submit the Google form. That is only that will be the test. So then that is about tomorrow's schedule. So I request all who have registered to join and participate in the written test. And then I will guide you how to, once the FDP is over, then your feedback link will be open in your portal. Then you have to fill the feedback form. Okay. Unless and until if you don't fill the feedback form in the Atal portal, you will not get the certificate. So 3 things are mandatory: attendance, that I will upload from my side, and written test marks also I will upload from my side after conducting of written test. And from your side, you have to appear in the written test, and you have to fill up the feedback form, which is available in your Atal login. You have your Atal login ID, so you can do that one. So one participant is asking, I think, one question. Manisha, yes, can you please ask the question, please? There is a message in chat box from Manisha, ma'am. Okay. So, ma'am, can you please ask your question? You are telling that you are going to ask one question. Hello. Yeah, please. Hello. You can ask one. You can ask the question if you want. You are not able to hear your voice, please. Or else you can post the question in chat box also, no problem. You are not audible. Hello? Hello? You are not audible, madam. Can you please, graphene. Yeah, Praveen sir.
Yes,
She
sir.
is asking.
Yeah. I understood that graphene research area. Yeah. Yes, madam. The graphene, when compared to graphite, the graphene having high strength We are also doing the research that's using the graphene particles. We are incorporating into the graphene nanoparticle into the aluminum composite. It's giving a very good properties, but since it's a little bit costly, but that graphene particles are when you add them into the aluminum, they are improved a lot in terms of properties of corrosion properties, wear properties. We observed when compared to the graphite, especially tribological properties improved a lot. Even the hardness also improved. When compared to the base material, we observed that we got the 40% or 50% higher than the base material. So graphene is also very good research area. We can use that in the composite materials also, or you can use that for the thin films also. It's a very good area, madam.
Thank you, sir. Anybody has any doubt?
Yeah, definitely.
So,
Definitely I'll send you, ma'am. If you send the email ID, I'll send to that Srinivas that all the areas. Yeah, you're possibly okay. Surely I'll send that all the areas with the help of the graphene you can get from the Srinivas.
okay, that's the today's session. Tomorrow again we will join the last day of our FDP at 10 o'clock. There will be technical session. Immediately after technical session, there will be a stress management session, and after lunch we will be having written test and feedback. Okay, feedback and followed by the written test. Okay, written test I will send you the Google form link in which you will find the questions. You will have to answer those questions, and you will have to submit in the specified time. I will give you the specified time, and the time of submission also I will give. So you please try to submit your Google form link. Anyway, whatever is there, I will try to communicate in the WhatsApp group, and also as well as through email. I will communicate all the instructions through the email as well as WhatsApp. Okay. So please, tomorrow you have to spare your time to appear in the written test as well as to give your feedback.